Okay, so now next semester you're going to do a lot more with graphing quadratic functions and graphing absolute value. You're going to talk more about shifting and stretching next semester. But in here, it's going to be very basic. But in section 10.2, the other part you got to do is be able to graph nonlinear functions. All right, nonlinear functions. So in other words, functions that are not linear. They don't look like lines. What you did in 10.2, what you turned in, those were lines. Now we're going to graph nonlinear functions. And the only ones that you have to be able to do would be quadratic functions and absolute value. Okay, so quadratic functions and absolute value functions. I need the 2 worksheets due today. All right. So section 10.2, quadratic and absolute value. So they're the basic functions for quadratic and absolute value are called the parent functions. So first of all, I'm going to graph the parent functions. And now let's talk about function. We talked about functions last time, and we used the vertical line test. Remember, the vertical line test determined if a graph represented a function. So what we're going to graph now, they're going to be functions. You'll be able to see using the vertical line test that for each, remember the definition for function, for each x coordinate, there's got to be exactly what? One y coordinate. All right, so the first parent function we're going to look at looks like this. F of x equal x squared. Now, this is function notation. That's function notation. That f of x, this right here, this symbol means f of x. That's how you read it. It does not mean f times x. That of here does not mean multiplication. It's just read f of x. Now, in the past, when you were given this line look like this, y equals 2x minus 1, and when we graphed this, we used a t-table, right? Yeah. And so we said, all right, to graph this, I just really need at least 2 points. So if x is 0, I said y equals 2 times 0 minus 1, which is 0 minus 1, which is what? Negative 1. And if x is 2, I said y equals 2 times 2 minus 1, which is 4 minus 1, which is 3. Okay? Now we graph this, just to show you real quick, when we graph this, 0, negative 1 is here, 2, 2, 3 is here, and I get this line, right? And that's a function because it passed the vertical line test. So since that's a function, I can also write this using function notation. So this y, the letter y, I can also write as f of x. So y means the same thing as f of x, as this notation f of x. So I can write this function right here as f of x equal 2x minus 1. So there are several things you can do with that function notation. You could say graph f of x, which is this. Or you could say find f of, let's say, 2. Find f of 2. Now f of 2 means, look at this table right here. F of 2, that 2 represents what letter? X. So what I'm asking is, when x is 2, what's that y value? So just like this, when x is 2, what we did was, where we saw the variable x, what did we plug in? We plugged in 2. So this becomes f of 2 will equal 2 times 2 minus 1, which is 4 minus 1, which is what? 3. So you would say f of 2 equals 3. So if I had this real quick, let's suppose I had f of x equal 2x squared minus 1. F of x equals 2x squared minus 1. And all I want to do is to find out what f of, let's say, 3 is. F of 3. So find f of 3. So basically that says, wherever I see the variable x, what do I substitute? 3. And then I'm finding what y, or what value? Y though, right?
Yeah.
I'm finding y. So do y'all agree that an f of x means the same thing as y? So this right here you can say is same as y equals 2x squared minus 1. Okay, so that y and f of x are the same thing. That relation is a function, so instead of saying y, I can say f of x. And it's not just f of x. You're going to see in this course even that it could be g of x, it could be h of x. It could be any notation that looks like a function notation. So if we want to find f of 3, I'm going to say, well, that's going to be 2 times what? 3 what? Squared minus 1. And then using the order of operations, what do I do first? No, not multiplication first. Exponent. 3 squared is 9. And what's 2 times 9? And what's 18 minus 1? Yeah. So f of 3, you would say f of 3 then would equal 17. Okay? So we're going to do a little bit more with this idea of finding f of 6, f of negative 3, either at the end of this period or next class period. But what I want to do right now is go ahead and start graphing these so I can assign section 10.2. So in my math lab, it'll say graph f of x equal x squared plus 1. But first of all, we got to graph the parent function. Just know that f of x means the same thing as what letter? Y. So if you need to, for 10.2, if you need to, rewrite it as y equals x squared. So rewrite f of x as y. And then it looks like the lines, or the idea of how you graph the lines. So let's graph y equals x squared. Okay, so to graph these, here's the points you're going to use. Now, this is not a line, right? If a graph that's linear, both the exponents are what exponents for the variables? 1s. So this is not linear because this variable has what exponent? 2. This is actually quadratic. This is quadratic. So that's a quadratic function. And the graph, you're going to see that the graph is called a parabola. The graph is a parabola. And the shape looks like a U, kind of like this, where the arrows are pointing up, or it can be pointing down. Okay? Notice it's a little bit of terminology. Now, next semester you can learn a lot more about this because next semester you can learn about axis of symmetry, how to find it. But this low point right here, that low point, and this high point, that's called your vertex. So a quadratic function, when you graph it, always has a vertex. And when you graph these quadratic functions, you want to determine what that vertex is to help you. And when you do this next semester, you're going to use transformations. So if you know how to graph the parent function, this is called the parent function, x squared, then you can graph all the others for next semester using transformations. Now you're not going to learn transformations in here. We're just going to use the t-table in here. So the points you're going to use for x squared are these. For x, you're going to use 0, 1, -1, 2, -2. And then let's use 3, -3, because I think we have enough grid lines to do this one. So since that's not a line, you got to use a lot more than just 3 points, right? All right, and all you do is just wherever you see the variable, you plug in those numbers for x. So if x is 0, I get y equals what?
0 squared.
0 squared, which is what? 0. All right, So I'll plot the point 0, 0. So on your grid, you just go ahead and plot that point, which is the origin, right? Which is the origin. Okay. Then when x is 1, I'm going to say y equals 1 squared, which is what? 1. So I'll plot the point 1, 1, which is here. When x is negative 1, you got to be careful when using your calculator. With the negative values, you need to put that in parentheses. So for negative 1, you're saying this. You're saying y equals negative 1 in parentheses. And what am I doing to that x value? Squaring it. All right. So remember, there's a difference between this versus this. Those are two different things. You learned about that last semester before. Here, that means what's being squared that I'm pointing to? Negative 1. So what's negative 1 times itself? 1. Here, what's being squared? 1 only. What's 1 squared? But it's what kind of 1? Negative 1. All right, so there's a difference. So when putting negative values into the variable, put that in parentheses. So when x is negative 1, what should my y value be? Positive 1. Okay, so that's 1. When x is, so I'll plot the point negative 1, 1. So negative 1, 1 is here. Okay. Now remember, don't draw your line now. I mean, don't draw the graph now. I said lines is not lines. Don't draw the graph now. Keep plotting those points. When x is 2, I get y equals 2 squared, which is what? 4. So I plot the point 2, 4. So 2, 4 is here. Okay. When x is negative 2, I get y equals, in parentheses, negative 2, but I'm squaring it, so what's that? 4 as well. So negative 2, 4. So negative 2, 4 is here. And let's do the 3 and negative 3. When x is 3, I get y equals 3 squared, which is 9. So I'm plot the point 3, 9. So 3, 9 is here. And when x is negative 3, I get y equals negative 3 in parentheses squared, which is what? 9. All right. Now, again, next semester you can learn about symmetry and the axis of symmetry, and that will help you to graph these. Because it is going to get a little bit more complicated next semester because of the transformations. But these are just basic graphs here. So negative 3, 9. All right, and then all you do, notice it's not a line, right? Are all these points collinear? Yeah. Collinear means that they lie in the same line. Oh, yeah. No, they don't. That's not a line. I remember lines like this. All right. So it's a curve, though, right? Yeah. All right, so do the best you can with drawing this. Make it look like a parabola. Don't make it look like a V. A V is an absolute value. You're going to do that in a little while. So make it look like a parabola. All right, so this is your parent function. This is the graph y equals x squared. So in terms of symmetry, you can actually tell me what axis is the symmetry here. This parabola has what axis of symmetry? No, the axis. Y. The y-axis. So you see the y-axis divides it in the middle? Now that's just for x squared. Next semester you're going to see that it's going to be all other stuff for the axis of symmetry. All right, so notice where's the vertex for x squared, for the parent function? The origin. Okay, good. Vertex of the origin. So when you're graphing the quadratic functions, make sure you also, when drawing the parabola, that you also draw the vertex, or label, not label, but plot the vertex. Notice I didn't label any points, because with all these points it starts getting a little bit messy when you put all these numbers everywhere, so I didn't label anything. All right, so this is x squared. So in graphing the parent function, you're going to use 0, 1, 2, -1, -2, 3, and -3. You find the y value, and then you draw your curve, okay? For the parent function. All right, now, let's look at this. Suppose now I want to graph this. I'm trying to make sure I don't use one that's in your assignment. Let's see. So graph x. Let's graph y equals f of x equal x squared plus. Let's do 4. All right. Okay. Now, what I need to recognize is this: if I cover this +4, this +4 on the outside, see how this +4 is on the outside of x squared? Okay, and so you see that if I cover that +4, this what's left is nothing but the parent function. What's left is a parent function. Okay, so what I want you to use are the same x values we did here. So if the numbers on the outside of the parent function, see how you got to see this, write this down if you have to. If the numbers on the outside of the parent function, then I'm going to use the same x values that I used for the parent function. Okay? If the numbers are inside the parent function, you're going to see what we're going to do when we get to that. But if the numbers on the outside, use the same x coordinates. All right, so here we go. So what will I use for x? 0, 1, -1, 2, -2, 3, -3. Okay? And you can see what's going to happen, and that's going to give you an idea of what's going to happen next semester. So when x is 0, I get, and remember, f of x means the same thing as what letter? Y. So I get y equals 0 squared plus 4, right? What's 0 squared? And what's 0 plus 4? 4. So I'll plot the point 0, 4. So go ahead and plot that point 0, 4. All right, if x is 1, I get y equals 1 squared plus 4, which is 1 plus 4, which is what? 5. So I plot the point 1, 5, which is here. Okay? If x is -1, I got y equals -1 in parentheses squared plus 4, which is 1 plus 4, which is 5. So I plot the point -1, 5. You'll see the same kind of pattern, the symmetry about that y-axis, -1, 5. If x is 2, I get y equals 2 squared plus 4, which is 8. So I plot the point 2, 8, which is right here. If x is -2, I get y equals -2 squared plus 4, which is also what? 8. 4 plus 4 is 8. So -2, 8. Now what's going to happen now is that when I do 3, I'm just going to estimate where these are. So when x is 3, I get y equals 3 squared plus 4, which is what, 13? Is that correct? Yes, sir. So I plot the point 3, 13, so I have to estimate this. So let's see, this is 10, 11, 12, 13. This is what I did, I just estimated. So 3, 13 is about here. Okay. And then for negative, when x is -3, I got y equals -3 squared plus 4. So that's 9 plus 4, which is also what? 13. I got negative 3, 13, which is about here. And remember, this is quadratic, so you have to know the shape of a quadratic. The shape of a quadratic is that parabola, okay? So you all should know that the kind of function we're dealing with. This is not linear. This is quadratic. So the graph is not going to be a line. The graph is going to be a what? Parabola. Okay, that's the name of it. Looks like a U, but it's the parabola. And so when I connect the points I plotted, make it look like a parabola, make it curved, don't make it any straight lines. Do the best you can. And so there's the graph, f of x equal x squared plus 4. That's your graph. Okay? Now, I want you to compare that with the parent function. So you know where the parent function looked like. So next semester when you talk about transformations, you're going to take the parent function, you're going to move it. So next semester you're going to say, I'm going to take x squared, and I'm going to do what to it to get this? Move it up 4. So the number on the outside is a vertical shift. Number on the outside is a vertical shift. So notice you can't see it, and I didn't bring any transparencies, but I don't know if you can't see it very well, but see, this is x squared, right? But when I graphed x squared plus 4, what I did was I shifted all these points what? Up 4. So that's what you did, the x squared plus 4. So the number on the outside, you're going to learn that that's a vertical shift. Now, if it was x squared minus 4, what do you think would happen? It would shift down 4 units. So let's go ahead and do that one, x squared minus 4, just to show you. Now, remember, you got to remember what we talked about earlier, though. And I'm going to use g of x this time. Graph g of x equal x squared minus 4. But I'm not using f of x, but remember g of x, f of x, h of x, they all represent what letter? Y. All right. So if I cover, you see that negative 4? It's on the outside of x squared, right? Okay. So since it's on the outside of x squared, your x values that you're going to use are going to be the same as the parent function. So you're going to say 0, 1, negative 1, 2, negative 2, 3, negative 3. All right? And you know from what we just talked about from the previous two parabolas that this is a vertical shift. So plus 4 means to move it up 4, the parent function.
Down 4.
And then subtract 4 means to do what? Move it down 4, the parent function. All right. So if x is 0, I get y equals 0 squared minus 4, which gives me what? Negative 4. So I'll plot the point 0, negative 4. And so in the previous problem, in the parent function, what was the vertex in the parent function? What was the vertex? No. What was the vertex? 0, 0, the origin. In the x squared plus 4, what's the vertex? 0, not 0, negative 4, 0, 4. All right, in this one, what do you think is the vertex? 0, negative 4. Because all you do is just moving it up or down. All right, so here's the so here's the point 0, negative 4, right here. 0, negative 4. All right, x is 1. I get y equals 1 squared minus 4, which is 1 minus 4, which is what? Negative 3, right? Negative 3. So I plot the point 1, negative 3. So 1, negative 3 is right here. If x is negative 1, I get y equals, in parentheses, negative 1 squared, and then minus 4. What's negative 1 squared? 1 minus 4 is negative 3. So I plot the point, negative 1, negative 3. And don't forget about the idea of symmetry. And again, next semester, you're gonna learn how to find the axis of symmetry for any of these quadratic functions. When x is 2, I get y equals 2 squared minus 4. What's 2 squared minus 4? 0. Y'all agree? Mm-hmm. So I plot the point 2, 0. So 2, 0 is here. When x is negative 2, I get y equals negative 2 squared minus 4. What's negative 2 squared?
4.
And 4 minus 4 is 0. So negative 2, 0 is here. When x is 3, I get y equals 3 squared minus 4. 9 minus 4, which is 5. So I plot the point 3, 5. So 3, 5 is here. When x is negative 3, I get y equals negative 3 squared minus 4. 9 minus 4, which is also 5. So negative 3, 5 is here. Right. And then you just draw your curve, your problem. Do the best you can with it. Make it look symmetrical. Right. And so there's your problem. And so notice the parent function was here, and so this is shifted down 4 units. All right. So notice it, y'all do realize this is a function, right? How do you know this is a function? Okay, so for each, she's using the t-table. For each of these x coordinates, you see exactly what? One y coordinate. When x is 0, there's only one y. What is it? Negative 4. When x is 1, there's only one y. What is it? And so on. But you can also use what? If the graph is there, what else could you use? Vertical line test. All right. Okay? All right, so any questions on the quadratic when the number's on the outside? That's easy. These are the x values you're going to use. Okay. Let's talk about, well, what if the number's on the inside? So let's look at this one. In other words, here's what I mean. So you see how this looked like x squared minus 4? What if I had this? H of x equal, in parentheses, x minus 4 squared instead. See how that subtract 4 is on the inside of the squared, what's being squared? Here, what's being squared is x over here. So subtract 4 is on the outside. Here, what's being squared is x minus 4. All right, here's what I need you to remember. When it's on the outside, that's that vertical shift, right? Okay. When it's on the inside, it's the horizontal shift. So in other words, if you go back to that parent function, and if I had the transparency, and I don't have it with me, but if you did, you'd see it a little bit better. But basically, the parent function, if it's on the outside, it was either going up or what? Down. If the number's on the inside, it will either go to the right or to the left. All right. In the next semester, you're gonna be able to graph this to where it's actually moving right up, right down, right up, left down, and then stretching. You're gonna talk about stretching and all that next semester. All right. So what I need you to recognize is that, okay, so the subtract 4, if you read it like that, subtract 4 is on the inside. So it's what kind of shift? Horizontal. All right. So horizontal. All right. So here's what we're going to do. And so you're not going to use per se these same values for x. You're going to notice that when I do the t-table, it's not those same x values. All right. So here's what you're going to do. The vertical shift was easy. You could actually visualize it going up and down, and you knew what it was to do. If it was subtract 4, it went what? Down. If it was add 4, it went up. For the horizontal shift, it's just the opposite. All right, so watch what we're going to do here. So for this t-table, I'm going to use this. you see this right here where it's read as x minus 4? All right. Think the opposite, and you're going to see really why that occurs next semester. But what's the opposite of subtract 4? Add 4. So for my first x coordinate, I'm going to say positive 4. All right, don't do negative 4. Do positive 4. Okay? Think the opposite. You don't know why, but just do it. And now what you're going to do is your vertex is going to occur. What this is going to give you is your vertex. Your vertex is going to occur when x is what? 4. All right, so your vertex is going to occur. Your vertex is going to occur when x is 4. So let's find what the y value is. Y equals, in parentheses, 4 minus 4 squared. So when x is 4, what's my y value? 0, because that's 0 squared, right? And what's 0 squared? 0. So if I plot that point, what I've actually found was the vertex. I've actually found the vertex. All right, now here's what I need for you to do after this. So 4 zeros here. All right. Now, when we graph the others, I want you to notice something. Look at all the ones we just did. All those 3. You'll notice there was a vertex. And then I plotted how many points to the right?
1.
No. 1, 2, 3. And how many points to the left? 3. Same thing in the other one. When I found the vertex, I ended up also doing 3 points to the right. And then what? 3 points to the left. So here you found your vertex. You found your vertex, which is here, right? And all you need to do is pick 3 x coordinates to the right and then 3 x coordinates to the left. And it's easier to use increments of 1. So in other words, you're going to use 5 and what else? 6 and what else? 7. And then on the left, you're going to use what? Go increments of 1. It's easier. 3, 2, 1. Positive 3, positive 2, positive 1. All right, so once you find the vertex, first of all, you got to recognize it's a what kind of shift? Horizontal. So once you recognize the horizontal, you know where the vertex is going to occur. The vertex is going to occur when x is the opposite of what you see. So it's going to occur when x is 4. Find the y value, plot it, and then pick 3 points to the left, 3 points to the right. Do increments of 1. If you do more than that, you're not going to have enough space in your grid. That's why I said that. Because look, someone said 0. When x is 0, what's 0 minus 4? And what's negative 4 squared? 16. See, there's not enough grid lines here. So that's why I just said use increments of 4. Increments of 1 on either side. Okay, so watch how simple this is now. When x is 5, I get this. Y equals 5 minus 4 squared. What's 5 minus 4? And what's 1 squared? 1. So I plot the point 5, 1. Oops. I gotta find what I did. Oh, here we go. I plot the point 5, 1. 5, 1, right here. Okay. When x is 6, I get y equals 6 minus 4 squared. What's 6 minus 4? And what's 2 squared? 4. So I plot the point 6, 4. So 6, 4 is here. Okay? 6, 4. When x is 7, I get y equals 7 minus 4 squared. What's 7 minus 4?
3.
And what's 3 squared? Okay, so I plot the point 7, 9. So see, it's still within that grid, right? So if you had used other numbers beyond that, it would be way out there. So that's why I say, once you find your vertex, go increments of 1. So if my vertex was at 8, you would say 9, 10, 11. Now you'd have to estimate where 11 is, but you would do that. So you kind of see the shape of it on the right side? All right, now do the left side. When x is 3, I get y equals 3 minus 4 squared. What's 3 minus 4? And what's negative 1 squared? Positive 1. So I plot the point, 3, 1. And you see the idea of symmetry? Now let me ask you this. In the vertical shift, your axis of symmetry was the y-axis, right? In a horizontal shift, your axis of symmetry is not the y-axis. But you can see it. You can see it. If I took this pencil right here, and I said this was going to be my axis of symmetry. Axis of symmetry you're going to learn next semester. You don't have to know this for this course. But next semester you learn that the axis of symmetry goes to the vertex. Do y'all kind of see that this is going to be symmetrical around that pencil? Okay. All right, when x is 2, let's find the y value. I bet you can tell me what the y value is without even doing it. What do you think it is? Yeah, same one as this one. And when x is 1, what do you think the y value is?
9.
Very good. All right. So when x is 2, I got y equals 2 minus 4 squared. What's 2 minus 4? And what's negative 2 squared? 4, which is what you said. So negative 2 4s here. And then finally, when x is 1, I get y equals 1 minus 4 squared, which is negative 3 squared, which is what? 9. So I plot the point 1, 9. And then you just connect the dots. Do the best you can with making it look like a parabola. Do the best you can. And that's it. So you see that horizontal shift? So the vertex is not the origin now. The vertex is what? 4, 0. You just have to know, though, that for a horizontal shift, your vertex is going to occur the opposite of what you think. So let's suppose I'm trying to make sure I don't use one that I'm giving you. Suppose we had this. Suppose we had, all right, let's do this one. All right, let's suppose I had k of x equal x plus 2 squared. K of x equal x plus 2 squared. Now he would do the quadratics and the absolute value, same thing. What you need to ask yourself is this going to be a vertical or horizontal shift? What do you think it is? Horizontal, because that number is on the inside of that parentheses. So this is horizontal, right? This would be what kind of shift? Vertical. That's a vertical shift. Vertical shift. This would be a horizontal. It's easy for the vertical. Vertical, use the same x values you did with x squared. 0, 1, negative 1, 2, negative 2, 3, negative 3. Horizontal shift, do what we did. First of all, let's find the vertex. What's going to be the x-coordinate of my vertex? Think about our discussion. Negative 2. Negative 2. You think the opposite of what you see. That's going to be the x-coordinate of your vertex. Once you find the x-coordinate of your vertex, the other x-coordinates are easy to get. Okay? So when x is negative 2, what do you think your y value is? 0. You all agree? Y equals negative 2 plus 2 squared. What's negative 2 plus 2? And what's 0 squared? 0. And it kind of makes sense because for the parent function, we were at the origin. So if I move it 2 units to the left, it's still, the y coordinate is still what? 0. Okay, now here's what you would do. You'd plot the vertex. Plot the vertex. Which is, we said, negative 2, 0. And then the rest, for the other x coordinates, you just use increments of 1. You need, how many points to the right of that x? 3. And then 3 to the left. So, to be on the safe side, to make sure it fits within here as much as possible, I'm going to use what coordinates for x? -1. What else? What else? 1. Okay. What about on the left? -3, -4, -5. Okay. Y'all see it? All right. So you have -2, then you're going to say -1, 0, 1, and then you're going to say -3, -4, -5. All right? Okay, so now let's go with this. So when x is -1, I get y equals -1 plus 2 squared. What's -1 plus 2? And what's 1 squared? What? Agree? So I plot the point, -1, 1. Okay. When x is 0, I get y equals 0 plus 2 squared. What's 0 plus 2? And what's 2 squared? 4. So I plot the point, 0, 4. If x is 1, I get y equals 1 plus 2 squared, 3 squared, which is 9. So I plot the point, 1, 9. So now I know what the right side looks like. Looks like this, right? You agree? Do the best you can with drawing that parabola. And then you kind of have an idea what the left side is as well. So if x is -3, if x is -3, what do you think my y value is?
1.
Very good. If x is -4, what do you think my y value is? 4. If x is -5, it should be what? 9. The idea of symmetry. Okay, so if you didn't see it, though, just work it out. So if x is -3, I get y equals -3 plus 2 squared. What's -3 plus 2? And what's -1 squared? Positive 1. So I plot the point, -3, 1. If x is -4, I get y equals -4 plus 2 squared. What's -4 plus 2? And what's -2 squared? 4. I plot the point, -4, 4. And then if x is -5, I get y equals -5 plus 2 squared. And -5 plus 2 is -3. And -3 squared is 9. So -5, 9. And then just draw your graph. Right, so there's your parabola. Okay? All right, so you know what to do in terms of vertical shift. If it's a horizontal shift, you know the first thing you need to do in finding horizontals, when doing the horizontal shift, is to locate the vertex. Once you have the vertex, you pick 3 points to the right, 3 points to the left. Okay? And it's easier to go increments of 1. If you go too much further, you're not going to have enough room. It'll be way up here. So do increments of 1, just to make it fit as much as possible within here. All right, now let's talk about. All right, let's talk about absolute value. Same idea. So it took us a little bit of time to talk about quadratic. It's not going to take us much time to talk about absolute value because the idea is the same. They said the graph is not a parabola. The graph is not a curve like this. Let's see what the graph is. All right. So we graph the parent function first. So the parent function for absolute value parent function absolute value is this. Y equals absolute value of x. Y equals absolute value of x. I'm going to plot some points. So we can use these x coordinates for the parent function. The same ones you use for x squared. So which ones you use for x squared? 0, 1, -1, 2, -2, 3, -3. Same ones, okay? So it's very easy to deal with. Now, you got to remember the absolute value of a number is always what kind of number? Positive. The absolute value of 0, though, is what? 0. All right, so when x is 0, I get y equals the absolute value of 0, which is what? 0. So I plot the point 0, 0. Now, if you need some more grid, I don't. There's some extra ones. Grid paper. Where are they? You don't ran out? Okay. We'll have a few more here, although it's not enough. But these are the big ones. So you only get 2 front and back. So if you need some extra right there. And I don't think I have any other ones. Yeah, that's all I have. Okay. All right, so I plot the point 0, 0, which is the origin. All right. So you plot the point 0, 0. If x is 1, I get y equals absolute value of 1, which is what? Absolute value of a number is always positive. Positive 1, right? Because remember, absolute value measures the distance the number is from 0 in the number line. Distance is always positive. So 1, 1. If x is -1, I get y equals the absolute value of -1, which is positive 1. So I plot the point -1, 1. So notice the idea of symmetry as well. So a lot of the ideas that we just did with quadratic applies here, the idea of symmetry. If x is 2, I get y equals absolute value of 2, which is 2. Plot the point 2, 2. If x is -2, I get y equals absolute value of -2, which is positive 2. So plot the point -2, 2. You noticing the idea of symmetry still, right? Okay. If x is 3, I get y equals absolute value of 3, which is 3. If x is -3, I get y equals absolute value of -3, which is also 3. Now, notice that when I connect the points, it's not a curve, it's actually 2 rays. Looks like this. See it? Like a V. Looks like a V. So you got to recognize that the absolute value is the shape of a V. Quadratic is the shape of a parabola, that curve. It looks like a U, okay? All right, and notice that the vertex of the parent function is what point? The origin, just like the vertex of the quadratic parent function was the origin. So you see similarities, okay? Now, I'm going to ask you the same question I did with the other one. Is what I'm about to write, is that going to involve a vertical or horizontal shift that I'm about to do? Suppose we had f of x equal absolute value of x minus 5. Is that a vertical or horizontal shift? Vertical. Since it's vertical, you're going to use the same x-coordinates as the parent function. 0, 1, -1, 2, -2, 3, -3. And just remember, all you're doing is taking the parent function and doing what with it? Moving all these points down 5 units. Down 5 units. All right, so you're going to use the same x-coordinates as your parent function. 0, 1, -1, 2, -2, 3, -3. Okay? All right, so here we go. y equals absolute value 0, subtract 5. Negative 5. Y'all agree? So I plot the point, 0, negative 5. And just keep in mind that it's supposed to be moving down, and it is. So instead of the vertex being at the origin, it's now at 0, negative 5. If x is 1, I get y equals absolute value of 1, subtract 5, which gives you what y value? Negative 4. So 1, negative 4. Kind of makes sense. I just want you to remember this. See, here's the point 1, 1. Y'all agree? From the parent function? Just look for a moment. So I'm taking this point and I'm moving it where? Down 5. So watch. 1, 2, 3, 4, 5. Is that what I got? Yeah. Okay. All right. So use those ideas to help you. So here's 1, 5. I mean, not 5, but 1, negative 4. All right. Then the next one, when x is negative 1, when x is negative 1, I get y equals the absolute value of negative 1, subtract 5. What's the absolute value of negative 1? And what's 1 subtract 5? Negative 4. So I plot the point negative 1, negative 4. Negative 1, negative 4. The idea of symmetry. If x is 2, I get y equals absolute value of 2 subtract 5. What's the absolute value of 2? And what's 2 subtract 5? Negative 3. So 2, negative 3. 2, negative 3. Remember, that's a v, so it is kind of looking correct. See, all these points are lying on the same ray on each side. If x is negative 2, I get the absolute value of negative 2 subtract 5. What's the absolute value of negative 2? And what's 2 subtract 5? Negative 3. So I plot the point negative 2, negative 3. Use the idea of symmetry to help you. If x is 3, I get y equals absolute value of 3 subtract 5. That's 3 subtract 5, which is negative 2. So 3, negative 2. 3, negative 2. So I know what this side looks like. Looks like this. When x is negative 3, I also get what? Negative 2. And then I now have this side. Okay, so there's your graph. All right. Now, is this one going to be horizontal or vertical shift that I'm about to do? Huh? What was that? I'm sorry?
Wait, which one?
I haven't put it up yet.
Oh,
All right. What's this one? So y equal absolute value of x plus 5. Absolute value of x plus 5. Horizontal. All right. Now, locate the vertex. The vertex will occur when x is what? Negative 5. Very good. So the vertex is going to occur when x is negative 5. All right. And so let's find the y value. Well, you know what the y value is. Is going to be what? 0. Okay. But let's just see if you if you didn't, and make sure you understand why we say 0. Because look, here's the parent function. The vertex is at 0, 0, correct? So this says I take all my points and I move it to the left 5 units. So watch. 1, 2, 3, 4, 5. It's the y coordinate is still what? 0. All right, so y equals absolute value of negative 5 plus 5, which is just what? 0. So I plot the point, negative 5, 0, and then from there you go 3 points to the right and then 3 points to the left. Do increments of 1. And that's all it is. So negative 5 zeros here. And so knowing that my vertex is here, I'm now going to use what x coordinates? -4, -3, -2. What about on this side?
8, -8, -7, -6.
Yeah, -6, -7, -8. Okay? So you're going to say -4, -3, -2. And then on the left side, you're going to say -6, -7, -8. Okay? All right, but remember, the horizontal shift, you got to locate where that vertex is first and then go 3 to the right, 3 to the left. Okay, when x is -4, I get y equals absolute value of -4 plus 5, which gives me absolute value of 1, which gives me 1. So -4, 1. So I'll plot the point -4, 1. Okay. When x is -3, I get y equals absolute value of -3 plus 5, which is absolute value of what number? 2, right? Which is just 2. So -3, 2. When x is -2, I get y equals absolute value of -2 plus 5, which is absolute value of 3, which is +3. And then look, use the idea of symmetry. Use the idea of symmetry. So for -6, yeah, see when I went 1 unit to the right of that vertex, what was my y value? 1. So if I go 1 unit to the left, my y value still has to be what? 1. So you know right away that when x is -6, what's my y value? 1. Now, if you need to double check, go just up here and write it. Say -6 plus 5 is what? -1. Absolute value of -1 is what? +1. So when I went 2 units to the right, I got my y value to be 2. When I go 2 units to the left, which is x equal -7, I get my y value to also be what? 2. But if you don't see it, if you don't see what we just did, then work it out. When x is -7, I get y equals -7 plus 5, absolute value. What's -7 plus 5? -2. Absolute value of -2 is 2, right? So I plot the point, -7, 2. I forgot to do -6, 1. So here's -6, 1. Here's -7, 2. And then for -8, what do you think my y value should be? 3. So I get y equals absolute value of -8 plus 5, absolute value of 3, which is 3. And so there's your graph. Okay? So that's the graph of y equals absolute value of x plus 5. So as you do these, just it helps to determine, first of all, if it's if it's a parabola or a V, then determine if it's a vertical shift or horizontal shift, and then you go from there. All right, now look at this. I think, let me check something real quick.